Welcome to the Async Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Welcome to another episode of the Async Coding Interview Data Structure series. In this episode, we'll be looking at the Doubly linked list implementation. So stay tuned and brace yourself before impact. So first of all, we'll start with defining what a doubly linked list is. There was an episode prior to this. It was the episode explaining the introduction to linked list. There, I did justice to every type of linked list and their definition. But I'm just repeating it so that it can stick inside you. So the definition of a doubly linked list. A doubly linked list is a linked list with each of its individual nodes having two pointers, one to the previous node and one to the next node. So if you couldn't grab this definition, the next slide I'm going to show a visual depiction of this data structure to help you understand better. So here is the visual depiction of the doubly linked list. As you can see, each of the node have two pointers, one to the next, one to the previous. So the arrow going from the right to the left is the one pointing to the previous nodes. Then the one going from the left to the right is the one pointing to the next nodes. So it's that simple. I was just trying to think of like if how I can relate this to an object in the real world. I don't have any example, but I think a chain, like a chain that is not tied, each of the interlocks have a connection to its next interlock and a connection to its previous interlock, something like that. So you can use that as a physical depiction of what a doubly linked list looks like. So next up, we are going to get into the technical part, that's the implementation, and we'll be explaining and visualizing each procedure it takes to implement a doubly linked list. Okay, so this is like an object that is similar to the doubly linked list in our real world. So this is a chain, and as you can see, it has that something like that previous and next pointers. That this relationship between these two interlocks of the chain. So it's that simple. So I just wanted to use this to give you more like a visual depiction, so that you can easily imagine in your mind what a doubly linked list is. So now we'll be looking at the implementation of the doubly linked list. So stay tuned because this part is going to get tricky, complicated, and confusing at first. But if you take your time and listen to every word I say and watch with rapt attention, you should be able to understand how to implement a doubly linked list on your own. Okay, so this is the implementation of the doubly singly linked data structure. So this is the first step we take. We create a class for for each node object in this doubly linked list. So this node class is going to have four precise attributes. If you watch the previous episode explaining the singly linked list, you'd have seen that it had only three attributes. That was the value, the next pointer, and the index. But there's a little variation in the doubly linked list. It's supposed to have four, two of the attributes being the next pointer and the previous pointer. So that's just what it takes. And note, you can implement this in any of your preferred language. This is just a pseudocode. Pseudocode being an imaginary code, a code of an imaginary language with no specific syntax. So next we'll be looking at the next procedure to take to implement this doubly linked list class. There is no much difference between the singly linked linked list and the doubly linked list. I mean, in the class perspective, no attribute change. When it initializes with a head that has a null value assigned to it at first and a length of 0. So it's just pretty much the same. So what it does here is that you write the class, the initialization function in Python is definite, right? And then in JavaScript is constructor. So list.head is equals to null. That means the head attribute is assigned to a null value at the beginning at its initialization, then the length is initialized at 0. So we'll be looking at the insertion function, and that's where the real magic happens. So this is the insert method of the W linked list data structure. So this method is what makes nodes to enter the collection in the first place. This is where the real magic happens. So I'm going to run through the pseudocode of this method and explain every line and how it works and its function. So we are going to start off with declaring the method, and then there's this conditional, and what this conditional is going to check is if the head of the head attribute of the doubly linked list is null. And why is going to check this? If you didn't watch the previous episode explaining the singly linked list data structure, you may have a hard time understanding this part. So we'll start with the else method. So it says if the linked dot head attribute is not null, run this particular code snippet. So we'll be explaining what this code snippet is. So we'll start from the else condition. First, it creates an instantiation of the node class. So that means it creates a node object. Then pass in the value arguments as the value attribute of the node object. Then pass in its next pointer, the next node, which is the current head attribute of the doubly linked list. Then previous its previous attributes, this previous pointer is going to be pointing to null because there is no element before it. Then its index is going to be the current length. So then after that, it changes the head to that node object and then increases the length by plus. Remember, this is when the head is null. So when the head is not null, this is what happens. The same process is repeated, but now there's a slight variation. First, a node object instantiation is made at first. Then the head attribute, the head dot previous attribute is going to be equals to the node object that is about to be imputed into the linked list. Then the head will be set to the current node attribute. The current node object, and the length will be increased by 1. So why were we putting down null? Why were we checking if the head is not null? Is because of the null. If this attribute wasn't put there, it's going to cause an error in our code because the null doesn't have any attributes of previous, head, and the rest of them. The null is just null, and it's not an object instantiation. So if it's going to go on runtime, it's going to cause an error there. So it's as that simple. I'll be also leaving a visual explanation of it. That means we'll be working with live examples of this pseudocode, so you see how it works fully. Okay, so this is the practical explanation of the insert method of the doubly linked list. So let's say that this is an array of two elements, and we want to add these two elements. We want to change it to a doubly linked list, and with that insert method pseudocode I wrote, we are going to try to implement the function with this practical. So at every initialization of the doubly linked list, the head is always going to be null. So that's one. So Let's say we want to insert one using that method. Let's run through. So that node object is going to be instantiated, and let's make it an object. Let's not just use those classes. So we set the value to 1 because 1 is about to be inserted. Then we set the next attribute of this node object to the current head, which is null. Just put it in bracket head so you see it clearly. Then we set the previous attribute of the node object. We set it to null because we don't have any node before it, so we just set it to null too. Then the index is going to be equal to the length of the linked list, which is currently 0. So index is equal to is equal to 0, and that's it. This is just the first step. Remember, this is still in that node variable. So what we are going to do here, because of the head is null, remember that condition, the head will just be changed to this node object here. So it's going to be equal to this node object. So let's update the head. So the head is now going to be this node object. So we are just going to update the head, and it just is as that simple. Zero. So this is what the current head is. Now we have already inserted 1. So 1, that's node 1 is the current object at the head. So let's say we want to add 2. And now you remember that condition that I said, if the head is not null, that it should set the previous and the rest of them. We're going to see that magic happen right now. So this is what we are going to do. The node object will be instantiated again, and now the node object is going to be instantiated again. Node, remember we're trying to insert a value, is going to be equal to 2. Then the next is going to be the current head, which is this current node at the head. So next is equal to 1, and is next. I just want to write it in a way that it can be clear to you. Okay. Next is going to be equal to, I'll write it in full, node dot value 1. Why is this in disconnecting? Next, no, previous, no, because this is the next is always the current state of the head. Why did it sing clear? Oh, index 0. I have to rewrite. Okay, so after this, what's the next attribute? Okay, the previous will always be the previous of every node object instantiated will always be null till a new node is added. You're going to see why in a second. So the previous is always going to be null, and then index is going to be 1 because the length of the doubly linked list now is 1. So it's going to be 1. Index 1. Now, before we change the head to this current node instantiation, there's something we are going to do. We are going to do something like this. The head dot previous which is currently null, is going to be equal to this current node we want to instantiate. So it's going to update this head. So this head will stop looking like the previous of this head. After this thing is run, it's going to be like this. The previous will change, cease from being null, and it becomes this current node. No, there's space to write. It's not that writing it again is going to be pretty messed up. Okay, sorry, my screen just went blank for a moment. So the previous of the current head is going to be the node to be instantiated. Then when that is changed, the head will be set to that node as usual. So it's as that simple. So that's how it works. The previous, before you change the head, you set the head's previous to the node to be instantiated. So that's where it gets a little bit confusing for the singly linked list. But I hope you understand it. So next up, we are going to be looking at more special methods that also makes the doubly linked list functional. So this is the get node method of the doubly linked list, and what it does is that it takes an argument called the index and fetches an individual node from the linked list collection. So how does it do that? It creates a copy the copy of the head attribute of the linked list in a variable named copy. Then it traverses through that copy. How does it traverse through that copy? It uses that copy.next. It keeps on going to the next node, to the next node, to the next node till it gets to the bottom. And if it finds any node with the index of the index the user is searching for, it breaks the loop and returns that node. But if it doesn't and it gets to the bottom, which is null, it returns false. So it's as that simple. Okay, so this is the check if exists method. So it's just similar to the get node method. It's just like the same thing with the get node method. What differentiates them is the function. So it's used to check if a node exists, a particular node exists in a linked list collection. So it functions the same way. It creates a copy. It traverses through the collection to check if it can find any node with a value equal to the val argument of the function. So if it doesn't find, it returns false. It's as simple as that. And like I said, if you haven't watched the previous episode, I advise you to watch the previous episode, because yeah, we went into details on most of these methods. And that previous episode will give you more like a foundational knowledge of what we are going to do here. So the previous episode was actually on the singly linked list, its implementation with features. So I advise you to go and check it out. So this is the remove method, and as its name suggests, it's used to remove nodes from the doubly linked list. So this is what it does. It takes the index of the node you want to remove, then it gets the previous node, that's the node before it, and then calls the delete method of the node class. So in that delete method, what the delete method does is that previous node that is called, it sets the node you want to remove, that's his next node, to his next node. Then after he sets it to his next node, he changes that next node previous to the previous node of the node you want to remove. It's that simple. So you might not grab it at first, but if you look closely at the pseudocode, you'll be able to understand the point I'm trying to get across. And also, if you didn't understand this the explanation of this method that well, I advise you to go back to the singly linked list, its own remove method. Yeah, I think I did more justice and I went into more details about the remove method of the linked list. Okay, so this is the print method, and as its name suggests, it prints every node in the doubly linked list, and it just works like the get node. When I mean like it works like the get node, it traverses, and instead of looking for something, each node it traverses, it prints them out. And mind you, this my pseudocode implementation. Its print output is, let me call it, basic and minimal, and not too beautiful, but in my Python implementation I made it fine and I decorated it more. So still stay tuned because that's the next thing coming up. Okay, so this is my Python implementation of the Doubly linked list. I'll leave the link to it in the description. So let's test out each of those methods. Let's start with the print method. Test.print. Okay, let's make this command line bigger. Okay, as you can see, like I said, I made it finer, so you can see the arrows that pass that message. Every node in it is printed out. So let's test the get node method next. In this implementation I named it get index, forgot to change it. So we'll use a print statement so that we can see the value up front. So test dot get index, let's say the first node is 2 and it has the index of 0. So okay, and then we do dot value so it can show clearly that we got it. Okay, so okay, it came down all the way here, so you can see it 2 was returned, so it's working. So the next method I would like to check is the find method. So let's find if 2 exists in the linked list and it should return found, but if it didn't find it, it will say not found. So let's do something like 112, not found. Got it here, not found. So next up we test the remove method. So let's remove 6, and 6 has the index of 3, so just remove 3, give it that index and try to find 3, and you will see that you return not found. Not found. So everything is working perfectly. So I'll be leaving the link to this implementation, and also I'll be making a JavaScript implementation of our JavaScript test, and also maybe a PHP implementation so that PHP developers too can catch on. Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I would be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.